All right, this is the last question here. If you notice, the previous ones are all multiply and divide with scientific notation, and so that's all that's happening here. That's the only thing we've learned is to multiply and divide with scientific notation. And we have, what do we have here? One water molecule weighs this much, has this much mass. This is actually a really, really small number because it has a negative exponent, a really, really large negative exponent here. So it has a mass that's incredibly small. And we've got, a lake. And this lake is huge. It's massive. And because it's got 16, that's a much bigger number. So we want to know how many water molecules are in the lake. So we've got a lake. It's 1.2 times 10 to the 16. That's how big it is. And we want to divide that by 3 by the mass of every molecule. And then that will find out how many we can actually fit in. So we've got this huge lake, and we're dividing it up into a bunch of little things, a bunch of little groups to see how many we can actually fit in. Now, this is a little bit more difficult to do, 1.2 divided by 3. So what I'm actually going to do first, and this shows if you can do something like this, if you can understand this, this shows that you have a really good understanding, is that I'm going to make this a 12. So the bottom is 3 times 10 to the negative 26. And you'd want to make it a 12 because 12 divided by 3 is 4. It's really easy. You might not know what 1.2 divided by 3 actually is. So to make this a 12, you need to know how to balance things. So I've added 1.2 and I made that a 12. I made this number bigger by moving the decimal spot once. So I need to make this smaller once. So instead of 16, I'm going to make it smaller. I'm going to make it 15. So that's how I did that. I looked at this and looked at this. I moved it one bigger, so up by 1. Therefore, I need to lower this side by 1 exponent, and I made that a 15. It was 16. Now I made it a 15. So now I can actually do the question. 12 divided by 3 is 4. And then these are the same base, so 15 subtract negative 26. Now, whenever you subtract a negative, that's the same thing as adding. So I get 4 times 10 to the 15 plus 26, 10, 20, 30, 41. So this is huge. This is a giant number. Look at that. It's a positive number, and it's 41. It's way bigger than anything else. So we can fit 4 times 10 to the 41 molecules. That is a 4 with 41 zeros at the end. I don't know how many trillions of trillions of trillions that actually is, but it is huge. So that's how you do that. It's not too difficult once you know how to do it, and there's a little sneaky trick there where you can take 1.2 and turn it into 12 as long as you balance the other side of the scientific notation, and then it's just a simple division and subtraction of exponents.